So welcome everyone to our first pre-stress webinar for international webinar for this year. My name is Ciprian Tibea, and I will be your host for today. Today's topic, of course, is about pre-stress and learning how to use it, a short introduction, also a more in-depth view about its functionalities. So yeah, without further ado, let's go straight into it. So what is prestress? Well, prestress is an element design software. You can use it to design beams, prestress beams, Holocaust slabs. And the best way for us to welcome the new users is through our prestress wiki page, where basically you have all the help that you need dynamically. So whatever topic that you are interested in, you just type it here, just type search. So great. And it will take you to all the subjects containing that search parameter. Now, probably most of you didn't had any contact with prestress before. So therefore, I will just take you through it from start to how to fully define a project. And then we will go to more in-depth, as I said, details about prestress. So of course, we will have to give a name and a length for our beam. We will take a beam for this example. So let's take a, I don't know, 12 meters beam. Then we can select from the database either a standard sections or non-standard sections. If we go for a non-standard, then we will have all the variables to define ourselves. So we will give it a name, of course, and then we will just have to fill in all those geometrical details of the section. But for this example, I will just go, with the standard one, as I don't want to lose a lot of time. So we will just take this trapezoidal shape section. All right, then maybe this one is too low, maybe not. We'll see. All right, so we have defined the section. We will have to define if whether it's a constant or a variable I beam, D beam, roof beams, etc. So if I go, for example, and select a sloped I beam, like a roof beam, then I have a different configurator. And of course, after filling all the geometrical details, I can define the beam. But let's stick with the constant section. And of course, I can add a topping on top of our precast beam, if I have one, or not. So yeah, that can be defined here. I can just select one, change one. All right, and then I will just click add. And this pop-up window, it will ask me if whether I want to also create a default file load combination. Let's click it. Then we move further. Now, our project has already been defined. So you see that all those stages have popped up, the full model and the load combination tab. Now, let's take it one at a time. So if we stick with the first menu here, we will have basically our beam. We have, the overview, the longitudinal view of the beam section and the transversal section. Here in this table, we will have the coordinates for the reinforcement, the length, the diameter, area, pre-stressing force, bond, and material type. Now, if we move to the next window, we have the stirrup window. So here we can either select the automatic design for stirrups, we can place it, default placing, or yeah, we can just define it manually as we want. Now, in the third tab, there is the reinforcement detail tab. Here we set parameters like concrete cover, the diameter of the reinforcement that will be placed on the top side, on the bottom side, the tendons, etc. So if I just click this one, like use regular spacing in each layer, and I click the code values, then I'm within the selected code values from the Eurocode, because I have selected Eurocode in the beginning. Now, here are a little bit more advanced calculation settings. For example, if we don't have shear reinforcement, like in the case of Holocaust slabs, this one will be active, shear calculation without shear reinforcement. Of course, we can select some adjustment factors and so on and so forth. For the fire, I have to select the fire exposure time, so maybe 60 minutes. Then I have to select the sides that are exposed to fire. So let's say bottom, left, and right side. Then I will have to select the details for the reinforcement, the class, the manufacturing, the pre-stress reinforcement as well, manufacturing, and then the aggregate type. And of course, here in this tab, there are the calculation sections. So, for example, if you want a particular section that is not included here, you can just add it manually, and it will work. Now, if we stick to this window, to this menu, we see here that we have different ways to define the reinforcement. We can use a reinforcement pattern like this. We can use a layer of reinforcement. We have the autosave, so we are safe. So we can use the layer of reinforcement. And then, as I see here, on the top side, I have diameter 20, passive reinforcement, because I see here the material. And then at the bottom side, I have tendons with a diameter of 12.9. And I can also see the concrete covers. So let's assume that we want, I don't know, 4 bars at the top, right? And then I want 4 tendons at the bottom. Then let's add 4 more tendons, so we have 2 layers. Now, of course, I can change the position. I can, by just using those coordinates here. It's just an Excel table, basically. So let's do a simple trick. Let's change the position of the first reinforcement bar. So instead of Y coordinate, which you can see the coordinates here, it's X, Z, and Y. I want 80. All right, so if I double click now, I can see that this one has shifted. All right, so now we will switch it back. And we move further. So the next step is to go into the load combination. So if I go into the load combination, of course, I see here 2 tabs, like the load combination tab and the long parameter tab. Now, in the load combination, of course, we define the load combinations, as you can expect. And in the long parameter is basically the creep and shrinkage. Now, the ones that have attended webinars in the past or that had contact with our software before know that if you just type, like creep and shrinkage StruSoft in a Google browser, we basically have this free to use page app that we created, in which basically it will calculate after you will input the input parameters, the creep and shrinkage for you. And you can also go, into seeing exactly how the calculation was made. You can click each formula if you want to see the value of each, factor in the formula. And eventually you have the values requested by this table. So, okay, but I see that I have only like two loads at the moment. It's like the self weight of the beam and the self weight of the topping. So of course I have to create more loads. So how do I do that? I go to input loads and I go to load cases. And in this tab, in this window, I can define another load. And of course the load type. So let's assume office area. And then the last one was not added, sorry. And now I can select those loads and I see that I have an empty, basically no load was added. So what do I do? The permanent load, of course, if I am to look at those stages, because those are the stages that the beam goes through from basically being casted into mold and up till the file load. So of course, the permanent load will probably be somewhere around this stage, in the intermediate stage. And then I can define the load type, like a uniform load, trapezoidal load, or a point load. And in each tab, I have more, specific parameters to input, like if it's a uniformly distributed load, which is centric, then I just have to input the value, like 10 kilonewtons per meter. I just have to select the beam. But then if I want the load to act just on a portion of the beam, then I will have to select those two values. If I want it to have an eccentricity, of course, I input the eccentricity and I explain in which part does the eccentricity act. All right, so if we are good with the 10 kilonewtons, we just added to all the stages onwards. So like this. Now, if I have an overview, I see that I have the permanent load coming from the intermediate stage onwards. Now, the live load, let's assume that it's in the final stage. And let's assume it's a 5 kilonewton per meter. And then, yeah, also centric. So I will just keep adding it from that stage onwards. Of course, I can have different loads in different stages under the same load case. It doesn't affect me. All right, so now we see that we have the live loads, we have the permanent loads, we have the self-weight, but we don't have the topping. The reason why we don't have the topping is that because we didn't specify in which exact stage is the topping being casted. So If I just go, for example, again in the intermediate stage, I see this window which is stopping, and I just select wet. Starting from this stage, the topping will be active. Now, in the first stage, it will be in you know, like a wet status. But if I click in the next stage, it will also already be in the hardened stage. So what I should do next, we didn't discuss about materials and about exposure classes. Now, each individual stage has this exposure class definition. So let's assume that our model is moderate humidity, and the material will basically progress as it is logic, like in the release stage. By default, this model has a C40 final concrete class, but in the release stage, we see that it is C30. Then in the storage and maturing is C45, and if I move on to transport, it's C40. Now, of course, I can modify it as I want. If I don't want C40 to be my final concrete class, I can select a different one, and of course, I can select what class is my beam at the demolding stage, what concrete class there is in the storage stage, and so on. So yeah, but we have to select the concrete class for the topping as well. So here, as I say, is C25, and if we want, of course, again, we can modify it, but for this example, I will leave it like this. Right, so now we basically have defined our loads, we have defined our concrete class, you know, our exposure class. We have placed a few longitudinal passive and active reinforcement, but I still see that in this load combination tab, I only have like the B1, which is the self-weight. Now, the way how to modify it is basically just click the other loads, and they will be automatically added with safety factors. And the safety factors can be also modified. So if, for example, your national annex specifies something differently, you can change it at any time. I will show you in a second. So now we have added the rest of the loads. And for example, let's modify this one, 1.15, 1.35, change. So it's that easy. All right. Now our model is more or less completed with the input data. Let's see how our calculation looks like. So the calculation is made in two different stages. The first one will calculate, you know, the moments, axial forces, shear forces, deflections, and you get to inspect it to see if that's the desired range you want to be in, if the moments are on par with your global analysis. And then there will be a second stage in which basically the full calculation will be made, and we will be able to go through each individual stage to check all of the verifications, to check you know, the deflections, moments, whatever we want to see. I guess it's going this slow because I have multiple prestress opened. Usually it's a lot faster. All right, so those are our forces, and I can see the shear force. I can see the deflection stage with precambers. Now I can see the axial force, and assuming that everything is okay with us, I will just click the design and calculate code control. This is the most basic way how to go through a pre-stress model the more simple way possible. And after this code control is being performed, of course that we will inspect the results and see if whether our design it's an optimal design. We will inspect to see how much reserve capacity we have, if the checks are met or not. So for this particular stage, I can see that ever since the release, my compression stress is too high. It's like 45% higher than the capacity. If I go further, I can see that it's twice the value. Let's go to see, just for the sake of the example, at the moment capacity, it's also a bit over shear topping joint. So basically, we see here that we have a failed model. So what we need to do, we need to go back to the start and reiterate. Of course, before doing it like this, I just did a bogus model. You do a pre-dimension of your element. So probably you will be almost on pair. Like here, you will probably have 0.8, like 80% of the capacity used. But yeah, so you will have to reiterate the entire process and go back from the start until everything is as you want. So if you aim like a 10% reserve capacity, you will have to have a 0.9, so 90% of the capacity is being used. All right, now going into a little bit more specific subjects from pre-stress, I have prepared some ready-made models for you. So in this case, let me see. Yeah, it's different tendon lengths. So if I go to the input geometry, I see here that the section, as it is at the end of the beam, it just has one layer of tendons at the bottom side. But what I did, oops, went to the older. What I did was basically splitting the tendons. So the way you do that is you place in reality some non-adherent tubes inside your beam for, let's say, 1 meter, and the second layer, basically has contact with the concrete matrix starting 1 meter inwards. I don't know if whether you can see it on your screens, but here you see that basically there is more thicker line. So if I just move the section here, I have like 2 layers of reinforcement. So it was pretty easy how to do that. I just modified the starting point of my second layer of reinforcement. You see here that Z is 69. So for all those reinforcement in second layer, I placed 1000 millimeters, that's 1 meter inwards. And of course, I modified the length as well. This one should have not been modified. Okay. So I changed the length as well to 14 meters. This was a 16 meter span. All right. So the reason why I did this was because if I have left both of the layers to start from the beginning to the end, the compressive strength of the section would have been, the check would not have been met. So therefore, I decided to move the second layer inwards. So then the transfer, it's made 1 meter inwards our beam. All right, so if I calculate it now, you will see that, yeah, it just gives me a warning. So whenever something is not okay, it gives me a warning, which I can select to ignore, or I can, just cancel and go and check the covers. For this particular case, I'm just ignoring it because it's not the subject of my model. Also the warning that the stirrups are less than the required minimum reinforcement. But if I look at the results now, I see that, all right, in the release stage, I have 65% of the compression stress intersection achieved. But if I look in the storage and maturing, I see that it's almost 100%. So if I would have left the second layer to start from 0, this one would have been 1 and something. Okay, and then I see that I still have like 14% reserve capacity when I look at the moment. Or when I look at the shear, I have like 40% reserve capacity. And in final stage B, it's like 24% reserve capacity. So I usually select this, code control window, but of course you have multiple ways to view and to check whether the data was correct or not. Now, let me see if whether this was the model with yes. So in the input data, I have selected at the stirrup reinforcement, we have here this button with a blue eye, which is end stirrups. Now, these end stirrups are very specific, and you will not see them added graphically on the section here. Those are, the stirrups that are placed in order to counter the effect of splitting, spalling, bursting, anchorage loss for the reinforcement at the end of the beam. So if I click this one, I see that, for example, I have selected a diameter 12 and the legs of the stirrups to be equal to 2. So then it will perform this additional check whenever I'm looking at the end beam results, like here. The calculation was proven to be invalidated because I played with the results. All right, so yeah, I can calculate it again and show it to you, but everything was okay. Let's do it just for the sake of the example. Then we will move on to our next topic, which will be the recessed beam. By the way, I'm sorry if your questions, if you have addressed any questions I haven't looked. It's just me in this webinar from StruSoft side, and therefore I cannot do two things at once. So I will take some selective questions at the end, and to the rest of you that have questions related to prestress, I will answer in the upcoming days via email. All right, so now if I look here, I see that it's okay. I don't have any red marks, so my end stirrups are okay. Probably a little bit over dimensioned, but yeah. All right, so let's move on to our next model, which is the recessed beam. Now, the recessed beam can be accessed only after you have made the design of the beam. So after you have made the initial design, you go here to Tools, you select the recess beam, and yeah, for some reason it shut down, probably because I have multiple windows opened. No problem. Right, we move to the first model because probably it needs a restart, and I don't want to do this. So if we look here, this is our recess beam tool. Of course, I can make recesses on both sides, the left side and the right side. And I have to fill in all those parameters, you know, like, I don't even know what is the full height, but yeah, that's 500, 500, 800. Just placing some values to see if whether, yeah, it doesn't work. Yeah, it does. So it has calculated, you know, the bearing plate. Of course, I have to select if whether here I want a 45 degrees angle, if whether this reinforcement is okay as it is. I can, you know, modify it. Whenever I hover my mouse, you see that that location of the reinforcement becomes blue. So it's really easy to, you know, see what reinforcement are you modifying. So of course, after I did all of those input data, I just click calculation, and if the calculation is okay, it will turn out to be green, as in this case. Otherwise, it will just give me a warning that something is not okay. So for example, let's change this value to 100 and this one to 400. Let's see if whether it works. No, it doesn't. So yeah, support position faulty. This is what you get with this recess beam condition. Now, what I forgot to mention in the model we have created together, I hope this is the one. Let's see. This is the one. All right. I can also place reinforcement inside the topping. So I can do, you know, top. I will just do one layer of reinforcement, for example, so 6. And it will just place 6 bars in longitudinal direction in this cross section. Another thing that you can do with prestress. Take another example. Okay, as I said, it needs a restart, as I stood with multiple windows opened for a long time. You can also do hollow core slabs. It only happens when whenever I'm having a webinar. It's like bad luck. I don't know if whether I should restart my computer, because then probably you will all be disconnected. I will try to see if whether I can close all windows and then open a new prestress window. Yeah, it works. All right. So we are safe. Tests. hollow core. And we will take a 6-meter hollow core, and we will select a standard section from Contiga. And we will just add it here and select the file load as well. All right, so in hollow core, what is different? So as I explained, if I go to calculation settings, I have to click this one without shear reinforcement, because yeah, hollow cores don't have any shear reinforcement, as you are well aware. Now, of course, I can define the reinforcement position, and so on and so forth. But the extra things that I can do is basically I can fill in some cores for a certain distance with concrete. So let's say like this, and I just filled 1 meter of the first core with concrete. And of course, I can do recesses if I want. So let's say 10, 10, 120. Is it higher? Yeah, 265. So I can add recesses as well. For some reason it doesn't display now. It usually does. Let's try 1000. And then the width. Yeah, I forgot to add the geometrical details. I just placed the starting point. Sorry. 100 at 265, 100, and then you see the recess here. All right, so this is the extra things that you have to know when you are dealing with hollow core slabs, that you have those extra features that you can use. And of course, the project itself will run similarly, with the exception that you don't place any stirrups, or you don't do anything in that regard. So the concrete will have to take all the shear force by itself. Okay, let's see if we have some questions. The minimum specifications for prestress are available on our website, but it's pretty low specification. So even if you have like a computer like 6-7 years ago, it will still run smoothly. All right, so I see that there aren't any other questions. If I forgot something, or if you you would like to trial any of our softwares, please feel free to go to our website and apply for a trial. If you apply, for example, for a pre-stress trial, you are a new user, it's your first contact. We usually do, like a one-on-one session before the trial starts. It takes about 40 minutes, and basically during this meeting, you can ask live your, concerns about the software, but the technical extent of it, basically everything you want to know. And it's the same for FEM design. It's the same for impact. So I encourage you guys to go to our website, to StruSoft.com, apply for a trial if you haven't done so already, and yeah, if not, I will await your questions on my email address. Thank you for attending this this webinar. I hope you liked it, and if there are, as I said, some specific things that I left out, let me know, and yeah, I will send you all the material via email. Have a good evening. Bye bye.